Okay, good people. Ne? Okay, I hope everyone is good. I hope everyone is good and good and good. So, I want us to continue with the quadratic function. Ne? We spoke about the value of a. We spoke about what when a is positive, our graph should be smiling face. When a is negative, our graph should be a sad face, right? So this time around, I want us to continue talking about the turning point. Let's talk about the turning point, guys. Ne? A turning point is definitely a point where our graph will definitely turn, right? This is a turning point. This is where the graph will turn. Turning point. As you can see this side, this is our turning point. Ne? How do we calculate the coordinates of the turning point, guys? Ne? So we're going to start with the x turning point, x-intercept of the turning point. This is the formula: x equals to negative b over 2a. We use this formula to calculate the x-intercept of the turning point. I hope I'm making sense. Ne? Negative b, this is b, guys. Ne? As you can see in the formula, this is b, negative b over 2a. This is a. I hope it does make sense. So this is what we do when we want to find the turning point, the x-intercept of the turning point, right? So after we have the x-intercept of the turning point, right? After we have used this formula to find the x-intercept of the turning point, what we simply do, we simply gonna use the x-intercept. Okay? We're gonna use this intercept and we're gonna substitute it into the original equation. This is our original equation. Meaning, I will simply go to the original equation, which is this one. Where we see x, we're gonna substitute the number that we found here. Right? We're gonna just substitute it on x here and here. Right? And then we'll find the y-intercept of the turning point. I hope it makes sense. We're still going to do more examples so that you can actually understand what we mean by this. But so far, that's what happens when we speak about the turning point of the quadratic graph, or rather quadratic function. Thank you. So let's check something else, guys. Ne? Yeah. There is something else we need to find actually here, right? What is it? Ne? We need to find the x-intercept, ne? Or rather the x coordinates of our graph. If I'm making sense, ne? The roots of our graph, which are basically the x coordinates. When I'm talking about the roots, what do I mean? I'm talking about this point. You see this point here and the point here. These are what I call the roots of the quadratic graph. So what do we do to calculate the roots of this graph? Keep in mind, guys, this is our formula. F of x equals to ax squared plus bx plus c, right? So how do I find the two x-intercept, or rather the two coordinates of our graph? How do I find those? Keep in mind, I've already said that C, this is our y-intercept, right? So now I need to find the two x-intercepts of our graph. What do I do? No problem, guys. Ne? Finding x-intercept, or rather x-coordinate of our graph. Ne? That's our formula, which is ax squared plus bx plus c. This is of f of x equals to, ne? Ne? As long, keep in mind guys, ne? This is ax squared plus, as long as our formula, ne? Yeah, as long as our quadratic formula, which is this one, as long as it has the value of a, b, and c, yeah, as long as we have the three values, so a, b, and c, what we can simply do in this case, in order for us to just quickly find the base, or rather the roots of our graph, yeah? The roots, the coordinates of this point and this point, what we simply do, there's a formula guys, quadratic formula, which is x equals to plus or minus sorry guys, it's x equals to negative b plus or minus square root of b squared minus 4ac all over 2a. Listen carefully guys. Now I'm saying, if we are given a quadratic equation, right, which has the value of a, the value of b, and the value of c, and we have to find the x-intercept of this graph, right? If we have to find the x-intercept of this graph, what we can simply do, we can simply use this formula. Using this formula is easy. Just substitute b, just put b